Well, my name is Beka. Let me tell you about the procedure to make a Daniel cell. As we know that a Daniel cell is voltaic cell, mean that it uses a chemical reaction to generate electricity via spontaneous redox reactions, mean that the source of electrons are the reactants, so that the reactants oxidize to give electrons, mean that also there is reduction because of oxidation reductions occurs simultaneously. They cannot occur separately, as we know that. So first, to make a Daniel cell, first we need to place a two compartment mean that if we assume this as a first compartment, also you need to make another compartment. Within each two compartment of the cell, you need to fill a zinc sulfate solution. In the other side, you need to fill a copper sulfate solutions. Then you need to dip the respective electrodes on the two solutions or on the two electrolyte. Means that for a zinc sulfate solution, you need to use zinc electrode as anode. For a copper sulfate solution, you need to use a copper as electrode. Then, as we know that if we want to generate electricity, it needs its passages, mean that there must be a conducting wire. So we need to connect two electrodes through external wire. This allows the passage of electricity, mean that the conducting wires are able to transfer electricity since they have delocalized electrons or mobile electrons, which allows carrying of electric current. Then, as at the moment we connect these two electrodes, the cell generates electricity, mean that it's able to generate electricity. But eventually it stops because of what? The compartments become charged. As we know that a zinc is active metal than a copper. When you compare the activity or the reactivity of a copper and a zinc is a more active metal. So that from a zinc electrode, each zinc atom loses a two electron and it joins or dissolves in a zinc sulfate solutions. The losest two electrons go through external wire toward to a copper electrode. At the moment those two electrodes sit on the copper electrode, the copper ion from a copper sulfate solutions migrates toward the copper electrode in order to be discharged. Because of what? In another compartment, zinc atom oxidized. So there must be reduction at the cathode. As we know that oxidation is occur always at the anode and reduction always occurs at the cathode. Then the copper ion migrates toward to a copper electrode in order to be discharged. Then each copper ion Cu2 plus gains the two electrons and become discharged and deposit at copper electrode. And the mass of electrode or the mass of the cathode become increased, whereas the mass of the zinc become decreased. Because of what? The anode of galvanic cell sacrifices itself. As a result, it loses its mass. Then, after some time or a few moments later, the cell become unable to generate electricity. That's why the two compartments become charged, mean that in the zinc sulfate solutions or in the zinc compartment there become overall a positive ion because of electrons migrated from the zinc electrode, whereas in the other side in the copper sulfate solutions the ionity of the copper sulfate solutions will be increased because of each copper ion or each Cu2 plus ions become discharged, so that In order to have a continuous flow of electricity, we need to connect these two compartments with a bridge that we call a salt bridge. From its name indicated that salt bridge is a bridge. It's generally it's salt in the aqueous state with a 5% of agar solution as a medium. These ions, or as we know that a salt contains two ions, namely cation and anion. A cation is a positive one and anion is a negative one. So that these two ions migrates toward to their opposite charge in order to maintain the electrical neutrality of the two electrolyses. Then they maintain the electrical neutrality of the two electrolyses. Again, the cell becomes to generate electricity. Here is a conceptual question. Why the cell becomes unable to generate electricity? Because of what? There is the charge difference among two compartments of the cell. This charge difference discourages the oxidations of zinc and the reductions of copper ion at a copper electrode. That is the main idea. I will come in another concept of the chemistry and I will make it clear for you.